Talk about 10 AI mental models every JavaScript developer should know. And start with number 1, the model spec. The model spec was released by OpenAI. And so basically the main idea behind the model spec is that software is a projection of the specs. It's not anymore about writing code, but rather writing specs, writing specifications. So basically you write your specifications in Markdown files, and then you have your agent generating the software based on that. So software is a projection of the specifications. The specifications look like this. They can be very high level, like respect the letter and spirit of instructions, assume best intentions, but then you can go deeper and even specify things about the implementation, like what library to use. This idea comes from looking at higher level languages like JavaScript, where we have this higher order syntax, which looks like English, but then we transpile that or interpret that into machine code by an interpreter, or in the case of compile languages like Java, by a compiler. It's the same pretty much with how React builds the UI, where we have state and props and then a component definition, and we take all that and we project that to an UI using React, which builds the fiber tree in the video. So you could say the UI, it's a function of the state, or the code, it's the function of the specs. So this idea is not old and it's been reused in the software world many times. Now, before we go on, let me introduce myself. I'm Bogdan, and 5 years ago, together with my brother Draosh, we started a senior dev where we help developers go to the senior developer and beyond. Check our free training in the description. And the reason I decided to make this video is because in one of our coaching calls, one of our mentees mentioned, hey, I'm really demotivated because I watch all these videos on YouTube and I feel like AI killed the software jobs and it's pointless to learn. It's pointless to get better. But remember, you always fear things that you don't understand. And so in this video, we're going to really break down the whole AI ecosystem and look at the main concepts. And by the end of it, ideally, if you're a developer, you'll have zero anxiety about your future. You'll know how to use the technology, and you won't be afraid that you'll be replaced by some LLM tomorrow. And so let's go back to the main idea, which is that the software becomes a projection of the specs. But what's a projection anyways? Well, going back to my mathematics class in my engineering degree, we used to project vectors on planes. And so basically you have a 3-dimensional vector, which is a series of values. In this case, because we are in a 3D plane, it's a 1, 1, 1. And then when you project that to the plane, it basically becomes a 1, 1, 0. This is pretty much what we do when we build maps from a 3D environment, but then you go on Google Maps and it's all flat, right? Basically, the space was projected on that 2D plane. It's a mathematical operation. Going back to projecting this vector on a plane, looking at code compilation in React, building the DOM, the question is, what do these three things have in common? And you guessed it, they are all deterministic. Well, a deterministic system in mathematics, it's a system where there's no randomness involved. And so basically, if you know the initial conditions of the system and the state transitions, you can guess the state it will find itself into. Basically, a deterministic model will produce the same output given the same starting input or the initial state. The most important part here is the no randomness involved part. Well, deterministic systems are very scalable and they are predictable and they are valuable. Civilization was built on top of deterministic systems like the combustion engine or the jet engine or any kind of precise concrete information systems like the CPU, the von Neumann architecture, and pretty much all the internet before LLMs. And before we move on, remember that no one will trust an elevator that failed even once, or a plane, a vaccine, any accounting software, supply chain software, banking, or any kind of critical infrastructure. Those things cannot fail. They need to be concrete and they need to give predictable outputs. Going back to their idea of software being a projection of the specs, what I found out working with Cloud Code is that there's nothing farther from the truth. Whenever you prompt an agent, no matter the agent, no matter the module, you'll get something that's pretty much all over the place. Sure, there'll be parts of it that look very good and very legit, but there'll be a ton of work to get from there to actually working software. And so what I've seen is that LLM code, it's at the very best an interpretation of the context provided. And different models might interpret your specs differently. And this is because randomness and hallucinations are not a bug, but rather the main feature of large language models. Now you might ask yourself, okay, what about using Gen AI for generating non-critical software like internal tools? Yesterday, Sebastian, the CEO of Klarna, one of the biggest financial unicorns in Europe and also in the US, mentioned that they will basically replace Jira and Atlassian and Bitbucket with a vibe-coded software that they did internally in 2 weeks. This is a real thing. People are starting to really reinvent everything and in building their own tools. But why are we reinventing the wheel? I mean, what about the principles of buy or build, or low-code tools like Zapier and Retool, or just don't build it at all? Is that really the most important activity that you can do as a financial institution, building your own internal ticketing system? I disagree. And I disagree because we don't buy software because of the code. We buy it because Jira, the vendor, they organized the problem space and made all those decisions for us. So we didn't need to go through that process. We buy the way they model the problem space and the solution into this executable artifact, executable knowledge that is a software. And what we buy, it's a knowledge service embedded or delivered as a software. We don't just buy the code. Code by itself has no value. Yes, you can go ahead and build your own ticketing system, but there's a saying that engineers will build their own coffin. So you can basically also redesign the tables or the chairs that you use or the keyboard and pretty much reinvent everything because you'll build it customized to yourself, and I'm sure you'll get so many productivity increases. Now, before we move on, let's remember software engineering is programming over time. Writing some code, writing a program, it's not that hard. Building software, it's hard. And so going back to this picture, a lot of people will tell me, well, maybe it's the prompts, maybe it's the specs. And the internet will say that you get bad results from AI because you don't know how to prompt it. That's the main idea, that there is a special way to prompt the AI that you don't know yet that will actually give you the results, the magical results everybody talks about. I looked up prompt engineering, but then it turns out it's already dead and something better came along, which leads me to the second concept, which is context engineering. Basically, context engineering means that you will not only fit the specs, but also style files like cursor files or Claude files generated by Claude Code. And then you'll index your whole code base and maybe some documentation websites, maybe internal documentation from your company, maybe some existing tests. And you kind of vectorize that and you feed all that to the LLM, and then you'll get a better result. And that's what they call context engineering. I failed to see the engineering part in it, but let's roll with it. The reason we can do that is because the context windows in models just went up. And so we saw AI companies basically competing to which one has a model with a bigger context window. And one of the biggest is Gemini 1.5 Pro, where you have 2 million tokens. How much is it? 2 million tokens. What does that mean? Well, you can basically tokenize text. And in general, as a rule of thumb, a token would be around 3 to 4 characters. So that implementation of the debounce function that we have right there, that would be around 51 tokens. 2 million tokens is basically 4 times cracking the code interview, the whole book in a single prompt. And let's be honest, a lot of the companies you probably work for have less business information or processes written down than 4 times this book. It really feels like we can just feed all that to the AI. Like the context window, it's not a limitation anymore. But what we're actually finding out is that there is context to it. That means model performance decreases as you increase the number of tokens you provide to it. And it does so exponentially. So you actually get much better accuracy if your context is very small, which means we are back to square one. And so it's easy to get LLMs to write code, but it's extremely hard to get them to build software. Now, if you're a JavaScript developer and you do want to get better at building software, we will help you become irreplaceable, develop senior level thinking, and thrive despite AI and layoffs. Check the link to the training in the description. How do we handle the fact that we want our LLMs not only to write code, but write code with the latest versions of the libraries we use? Like, for example, you wanted to use React 19. You don't want suggestions or examples or components that use class components or React 16. Well, that's where our fourth concept comes into place, which is retrieval augmentation generation. And this one is really interesting because normally you would have the user send a prompt to the LLM and get an answer. But with RAG, we basically have a context store. That means we take information from your company or the specifications of your product, and you kind of vectorize that and provide it as a context store. And so whenever a user asks something, a secondary model will embed that prompt and then find semantically similar content in your context store and put it together and stitch it together in a bigger prompt. And so you're passing much more context to the LLM. So even if, let's say, the LLM was trained on React 18, you can actually get answers from React 19 by giving it in the prompt using semantic search. This is a very good technique, and I believe this is actually the future of AI in the enterprise. The good news are, to build this kind of system, you just need to know a lot of software dev. Moving on to concept number 5, agentic coding. This term has been thrown around so much, but it's basically about recursive LLMs. So you've probably seen on YouTube, everybody, it's amazed by Cloud Code. I overspent too much money on it. I bought the max plan. It was money not well spent. I do recommend you to try it out, but don't go for the max mode. You can get most of the value in the lightweight mode, or get your company to maybe pay for it. If not, you could use Quen Code, which is very similar in performance. Agents are being hyped a lot, but in reality, it's a recursive self-calling large language model. Basically, it makes a pseudo plan, then it defines a success criteria that it extracts from the prompt, which is your base case, and then it keeps iterating onto itself or a sub agent until that prompt is basically achieved. So pretty much like a while loop, but you keep querying the LLM until you get a satisfactory results, or until the LLM thinks it got a satisfactory result. Now, a lot of people think this is kind of a jet engine level of technology, and it's mind-blowing and it will replace human workers. But then you go under the hood and you look at Cloud Code, and this is what you find. This is the actual code. It's literally just prompts the staff at Anthropic wrote, and they're being sent as you use the agent. A lot of things got my attention here, but you see this very important clause where it says, when you have completed a task, you must run the lint and type check commands with bash if they were provided to ensure the code is correct. Basically, they are telling the machine what to do by using prompts. And there are a lot of problems with using English as a language for coding. The number one is, remember, LLMs are statistical. So if you really want to make sure that the LLM ends up actually executing something you ask it, you probably have to repeat that clause again and again. It's basically like teaching a child. You would just repeat, and maybe if you're lucky enough, they'll end up doing what you say. But again, there's no guarantee. The only way they actually guarantee a good output is by having all those clauses repeated all over and then stitching them together and passing them into their models. Cloud Context Window, it's around 200,000 tokens, so they can afford to do that. Basically taking your code, indexing it, adding all the stuff around it, and then querying the LLM recursively until they get a great result. I do not think the software of the future will look like that. And I'm not the only one. As Etcher Dishra said it, a leading computer scientist, a very long time ago, I suspect that machines to be programmed in our native tongues, be it English, Dutch, American, are as damn difficult to make as they would be to use. And so using English as a programming language is not a new idea. And the reason why we have high-level languages is because we did wanted something that looks like English, but it's also precise and deterministic. And so programming languages are an evolution of the English language, not the other way around. Now, I highly recommend that you read the article. I'll link it up in the description because it will really give you a non-hype first principle thinking version of programming in natural language. And by the way, if you do want to know where your skills are as a JavaScript developer, check our free technical assessment. It's agentic, by the way, because supposedly that sells these days. It's actually not, okay? It's very deterministic. It will basically help you figure out where you are in the seniority scale, what are your technical gaps, and what are the next thing you should focus on to get to the next level. Okay, let's say you managed to vibe code your front end, and now you want to integrate it with the back end. That's where MCP comes in. And you probably heard about it because it has been all over the web. I mean, MCP really sounds like the next big thing, and it's the most important thing in tech right now. At least that's what you'll find if you just look for it on YouTube. It's a protocol, an open standard that enables the developers to build secure two-way connections between their data sources and AI-powered tools, according to Anthropic, the company behind it. Basically, if you want to build agentic LLMs, you'd have the user querying the LLM, and then maybe the LLM would end up making calls to external services, but all models will code their own logic. There was no standardization, and so Anthropic released MCP, which basically has two parts, a client part that will be used by the model and a server part that is basically like a wrapper around your existing API. And so when the model wants to do something on behalf of the user, let's say they want to call Google Maps to find a place, then they'll call the MCP client of Google Maps, and that ends up calling the MCP server, make a maps query, figure out where a place is or if it's open, and then the model will come back to you. It will digest that information and come back with the answer you needed. So it basically gives models the ability to call all these APIs without having trying to reinvent the wheel just by standardizing everything, because MCP is a universal standard. So OpenAI and all the other companies also comply to it. So you could switch even your model, but still use the same MCP clients and the same MCP servers. There's different things inside MCP, like tools, resources, prompts. And the funny thing is, when it came out, nobody really cared. But then 3 months later, it just blew up. The first MCP servers were actually maintained by Anthropic. They literally built like 10, 20 of them because nobody really cared when they released it, and it felt like it's not relevant. So one of the best way to add relevance is by building those servers into it. The way it looks under the hood is very familiar. You have JSON RPC, that stands for remote procedure calls, which are basically a way for the front end to run functions on the back end. You probably use TRPC, which is done with TypeScript, but remote procedure calls have been around ever since the 90s. You'd have them in Java, but then the world moved towards HTTP and REST APIs, and now they are coming back. Now, my biggest question is, okay, why don't we just use OpenAPI? If you just want to provide context to endpoints, you already have OpenAPI standards where you can literally define what each endpoint does, and we have REST, and those things are very mature, very easy to use technology, and a lot of people know it. MCP is kind of combining prompting and APIs. They claim it's for standardization. I do believe it definitely standardizes certain things, but again, we did have REST APIs between GraphQL, very established protocols for data communication. They also claim it's all about context because it allows you to kind of write a description for every tool, and then the LLMs kind of consumes that and knows what to do with a specific tool. But again, we had description fields both in GraphQL and in TRPC, and we have that in REST APIs too. So again, kind of redundant functionality here. They do this novel thing. A novel thing is that you can use tools and resources together, which is basically combining REST APIs with remote procedure calls on the same server. Again, nothing new. With remote procedure calls, you could tell the LLM to go and schedule a meeting for you in your Google Calendar. It's actually a function that you can execute on the server. It's not just calling REST endpoints to consume resources. And the last thing they added to it, it's kind of native HTTP streaming, because a lot of communication in those LLMs happens by streaming tokens to a certain endpoint or from a certain endpoint. So depending on how you set up your MCP, it might use HTTP streaming natively. Now, to be very honest with you, I believe MCP is just a glorified REST API with remote procedure calls combined in an effort that these model developer companies like OpenAI and Anthropic are making to give some technical substance to the AI coding movement. So they really need to argue that this is a great technology, and I really feel like this is sort of a made-up protocol. They are comparing it with HTTP, but it has nothing to do. It's not even as disruptive as GraphQL was back in the days. So I do believe that, at least from a technical perspective, it's highly underwhelming. Moving on to chain of thought. When DeepSeek came out, this was a big thing, probably in January, but it turns out LLMs can actually break down tasks just like humans do. Whenever you'd query one of those reasoning models, they will kind of break down your task and then give you finally a solution. What we found out is that even AI companies know that chain of thought, it's actually just a placeholder. They actually injected in prompts specific steps that the model has to take to solve the problem, but those were not reflected in the summary of thought, even if they were part of the solution. And that's when they started wondering if chain of thought is actually what the model is doing. Even if you ask GPT what chain of thought is, it will tell you that it's not a transcript of the internal neurons. It's not the internal thinking of the model. It's under the hood, the model is still doing just token prediction. The visible steps are actually generated with a helper LLM and constructed, so it's helpful for you as a human to feel like the LLM is thinking, but that's not the exact steps the LLM is following. Basically, it's just a fancy loading indicator. The LLM is really literally giving you the impression that it's thinking and doing the task in a sequential way, but that might have nothing to do with how it's doing it under the hood. Okay, now we're getting close to an end, but how can LLMs handle that much context? We've seen some LLMs handling 2 million tokens. Now, concept number 8 is time to test compute, also very popular. And in this one, you have the model coming up with 3 or 5 solutions, and then there's a reward model internally that chooses which is the best solution, and then it keeps iterating and doing that until it ranks the final output and finally gives you a answer. Again, when this came out, it was sold as such an improvement. You'll see this term thrown around just like all the others in all the AI talks. But in reality, what DeepMind found out is that for hard questions, this is actually detrimental. It only works for very easy questions. Like if you ask the model, what are the colors in the flag of the US? Then yes, you'll get like a better accuracy. But if you go into math problems, it actually works against you. So it's again one of those experimental things that was sold as an amazing breakthrough, but it turns out it's just another technique that can make sense for certain problems with certain models. Finally, there's the LCM, the language concept model. This is coming from Meta, where rather than parsing text into tokens and then into embeddings and having an LLM predicting the next token, we model the world in concepts. And to be honest, I'm quite excited about this one because I do feel like LLMs can be very useful into breaking down concepts and helping us human work. And I think it's a step to moving past the LLM and keep advancing into smarter machine intelligence. It's in the early stages, but I'll say I'll keep an eye on it. Finally, model distillation. You probably heard about this one, but basically you have a teacher model. That's a very big model that you kind of use to develop a smaller student model. A lot of people are claiming that's how DeepSeek copied ChatGPT. If you ask DeepSeek, who are you? It usually answers with ChatGPT, or at least it used to. The reason I'm excited about this is because a distal model can be 10 times smaller, but you still get very good performance. So as you see in the picture, a distal version of Queen 2.5 Math will give you 85.6% accuracy, whereas the full version will give you 3% more accuracy, but it's 10 times bigger. And so smaller models are the future because you get a diminishing return in accuracy, which means you'd have to verify the output anyhow, but it's a lot cheaper to run. And this is confirmed by the release of GPT-5, which you've probably seen was very disappointing. We are reaching a plateau. This probably happened already last year where OpenAI saw the models are not getting better. That's why they took so long to release GPT-5. Now, I've been using GPT-5 in the last month, and to be honest, I don't really feel any difference with the models from 2 years ago or even 1 year ago. I mean, yes, it's slightly better. The UI got better. It has the whole web search and the reasoning, but overall, it kind of feels the same ChatGPT. Now, you probably heard that AI engineers are making a lot of money. You saw Facebook trying to poach people from OpenAI, then OpenAI offering bonuses when GPT-5 came out. And so it looks like there's a talent fight and like being an AI engineer is the next thing. If you're thinking that you should become an LLM engineer, take into account it's a different career path in itself. There's a lot of mathematics, a different ecosystem, and different line of work than traditional software development. And it's very niche. So it's just like cloud computing back in the days. There's a few companies that will build it. They're building this AI infrastructure layer, and a lot of companies that are just integrating the models. So a lot of the money is done into that final mile, that final implementation. And that's where a lot of work is for software developers. There will be a couple of companies building models, but it's not that many. So it's a very small market, and it's a higher barrier of entry. You need a master's or a PhD, usually a couple of postdoctorate studies to really get in at that level. And there's huge competition because most of computer science students are moving towards graduating in ML and AI. You can check Stanford admissions numbers, for example. And also there's a negligible salary increase over the long term. So yes, there's a few people making tremendous salaries like in any sector. But if you take out the average, if you get to staff engineer and you stay there for a while in normal software engineering in the US, you will probably average out almost more cash at the end of the day. And again, you have more flexibility. The market is a lot bigger. So don't rush into this niche markets because yes, they sometimes have bigger compensations, but there's few positions. It takes longer to get one. There's not so many employers. You lose flexibility. Be really careful. Don't just look at the number itself. And so meanwhile, people are freaking out about AI and telling you should become an AI engineer or a prompt engineer or whatever that is. I get messages like this from our mentees. He just secured a senior front-end position with a great salary, a salary that it's even bigger than what people were getting 2 or 3 years ago, a 61% pay increase, building traditional SaaS, and it's over 6 figures in Australia, but we have a lot of cases in the US. And so beware that it's a cost of opportunity. If you're already good at software, you'll make a lot more if you stick to it, sell yourself well. Now, what you want to avoid at all costs it's coasting, especially if you're employed, you put your head in the sand, you just survive. A lot of people are doing their job with AI, just copy pasting, asking GPT everything. The next layer of round will catch you off guard, and you risk taking, 6 months to 1 year to find a new position if you're rusty, or settling for a job that will pay you a lot less. What we see people getting rehired after layoffs, they get a much lower salary. So don't coast, use your time well, get better at the craft. We also see a lot of the shiny object syndrome. People get into learning Python. Sometimes their own company is pushing them to learn Python, even if they are a JavaScript software engineer with TypeScript, React, Node.js. People go to build their own models or get some prompt engineering, set up some agents. It doesn't really help because, as you've seen, a lot of those things are hyped and sometimes there's no fundamentals. So you waste a lot of time on loose ends. Other people are just ignoring AI, but you can't do that. You need to learn the vocabulary, learn the main technologies, maybe even build an MCP server yourself and add AI-assisted coding skills to your resume. Companies are buying it. And so you want to use their FOMO, their fear of missing out to your advantage, and really use it to stand out. Other people are quitting software engineering. Don't do that. Careers are a long-term bet. If you constantly work and get better over a long period of time, you'll be an unstoppable force. When things get tough, remember showing up is half the job. I truly believe LLMs are a great tool. I think it's another step towards more intelligent machines, or at least machines that will make our work more fun. But right now, we are in the point in the market where the market is very far away from the truth. They are racing not towards intelligence, but rather towards raising money. And they're trying to sell certain products to their enterprise customers. That is the motivation of all those vendors, including Microsoft with OpenAI and Anthropic. And that's okay. It's not that they are evil, that's just the incentives they have. But as engineers, we want to take a step back and always apply first principle thinking and break those technologies apart to really see what are they selling to us. And what you'll see in the AI world is that the technical depth of the field did not increase exponentially in the last 5 years. We actually had a linear growth, some hardware improvements, and then the models were scaled vertically where they got much bigger. But now we realize that there's a plateau there. And just like the combustion engine reached a plateau back in the days, so technologies usually follow this trend where there's a lot of innovation and then you reach a plateau and then you need to move on and innovate again. Now, if you're a JavaScript developer, remember, we can help you become irreplaceable, develop senior level thinking using mental models, and thrive despite AI and layoffs. So check out the links in the description, and I'll see you in the next one.